let us see a very curious case of radar specification values through the eyes of probability. Okay, so let us take an event that you see a plane which has a probability of 5%. Okay, and there is a 95% chance that you don't see a plane, which means P of A complement equals to 0.95. Okay, now given that you see a plane and radar has detected it, okay, given that you see a plane and radar has detected it, would be written by probability that radar has detected it given that there was a plane, and the radar specification says that this will be 99%. Okay, so 0.99. Now there is a chance that radar has not detected it, okay, when there is a plane. This possibility, the radar specification says that there is only 0.1% chance that the radar will not detect it if there is a plane. Okay, now see the other side. Now there can be, the radar specification says that there can be a false alarm also, which means the radar has detected it given that there was no plane, because this is a no plane branch, right? So the possibility that there was no plane is 95%, you don't see a plane. Okay, and the radar detected it, say the radar spec says that there is only 10% chances, which means 0.1. Okay, there is also, the radar spec says that if there is no plane, the radar will be not detecting it 90% of the times, which means probability of B's complement given that there is no plane, which is given that A's complement is equals to 0.9%, right? 90% basically. So it will be 0.9. Now let's do some calculations here. Let's do P of A intersection B. Okay, this is a conditional probability. So this point here is A intersection B, which means A has happened and B has also happened. Okay, so according to the conditional probability and multiplication rule, this value will be this value into this value, so which will be your 0.05 into 0.99. Okay, so that is this value. Now, so similarly this value will be there is no plane and nothing has, and radar has still detected it, which means A's complement intersection B. Okay, and this point will be your A's complement, which is there is no plane and radar has also not detected it. Similarly, this point here would be your, there was a plane and radar did not detect it. So if you see here, what is the probability that radar has detected something? So that can be this as well as this, right? So this is a place where radar has detected something when there was a plane, and this is a place where radar has detected something when there was no plane. Okay, so this will be, according to the multiplication rule, this probability of a given event happening when the other event has occurred is the multiplication rule basically. So this multiplied by this will give you the result of this point, and similarly multiplication of this line versus this line will give you this line. So the probability that radar has detected something is the sub combination of these two, which means it will be 0.05 into 0.99 plus 0.95 into 0.1. Okay, now this is the probability that radar has detected something. Okay, now what is the probability that there was a plane given that radar detected it? Okay, so let's come to the reverse side of it. So radar did register something. Okay, here what is the probability that it was a plane? Okay, according to the conditional probability rule, this will be P of A intersection B divided by P of B. Okay, so a simple way to, and this will give you the value. If you replace the value, this will be 0.05 into 0.99 by probability of B, which is 0.05 into 0.99 plus 0.95 into 0.1. If you do the calculation for what you care, you will get a value of 34%, which means now you see that if a radar there is a chance that there is a plane given that their radar detected something, given that probability event B happened, the chance is just 34, which means there is only a 34% chance that there was a plane given that radar detected it. See, this is the curious case, right? the radar spec says that there's a 99% of the chance that we will detect it if there is a plane, and there is 10% of the chance of false alarm also. So this is your false alarm, right? Which means the radar detected it given that there was no plane. Okay, so you see the final percentage comes to 34%. Okay, and in this formula, which is the conditional probability, this can be explained basically in a fashion here. There are many ways to actually explain it. There is a subset set A and there is a set B. Okay, so this is the A intersection B. This area is A intersection B, right? So the probability of A happening given that B has happened is this by this, right? So this is your P A intersection B given by P of B, right? So probability, conditional probability of A happening B, this is, so there is a rule. Now you see how the radar spec goes for a toss when you apply the probability theory here.